Right, hello, my lovely people. I am going to go through this wedge question, which is from the 2022 paper. Right, 2022 there, and it can be found on the OneNote if you wish to look through the calculations. But what I'm going to do is I'm going to go through it at my normal pace, and hopefully explaining everything, probably drawing a number of graphs. But I'm not going to stop to give you time to think. I just want you to pause it if and when you need, or go back and watch it again, and even go work along with it and just pause it while you draw your graphs and stuff. So use the video in a way that helps you. So what this question is we've got particles A and B of masses m and 2m are connected by a light inextensible string which passes over a pulley at the top of the wedge. One particle resting on each of the faces, which is what the diagram says, which are smooth. And smooth means no friction. That is cool, because friction would make things less fun. So each of the inclined faces of the wedge makes an angle of 30, which is nice because we only have to have one cos 30 and one sine 30. We know what they are. We don't have a whole bunch of different angles. And then the wedge is mass 3m and rests on a smooth horizontal table. The system is released from rest. Right. Once we find the acceleration of the wedge, I suppose that's the least of our worries right now. You're going to be asked to find one or more of like tension, reaction, acceleration, whatever. So we kind of ignore that last sentence. Right now, we know we're going to have to find one. Let's just get our diagrams out and see what we can do. So I'm just going to take this one I've copied earlier, drag it down. I think this will be the first of possibly three diagrams. So this is one I'm going to use just to help me think. So we can just put it all together roughly, and then we're going to probably have to do some separate diagrams because it's going to get messy. So what I reckon is happening is we've got tension. A has been prevented from sliding down due to the string, and so is B, and it's the same string, so it's tension, and that tension is pulling down on the pulley. T and T there, cool. What else we're going to have is we're going to have our, I think what A it said was mass m, so that's going to be mg down, and this is going to have to be 2mg down. I will write a bit better when I do the better diagrams. And the weight of the wedge is 3m, so it's 3mg down. I'm going to call this thing W, hopefully for obvious reasons. Then what's happening? So A is on one of the angled surfaces, so it means that because A is sitting on it, we have the reaction at A, and because B is sitting at that, we have the reaction at B. And remember, reactions are perpendicular to the surface they're on. And then we have the reaction of the wedge on the ground, or the smooth horizontal table. So I'm just going to extend that line there just so it looks a bit better. So those are the forces acting on each thing. Now, if it said do it on separate diagrams, we do it on separate diagrams and get marks for it. I'm going to do it on separate diagrams anyway. And hopefully we'll see why when we see how many lines we're going to have to draw. And let's see, what do we reckon is going to happen? I think what's going to happen is the B is going to go downwards because it's a heavier one. So I reckon our first acceleration is A is going to be that way as the arrows go down and to the right. And then A is going to go up and to the right. And it says the wedge rests, so the wedge is free to move. So is the wedge. I think because the masses on the wedge are moving rightwards. So the kind of the M and the 2M from A and B are moving that direction roughly. I think it means the wedge has to be moving in that direction. Now again, if I got it wrong, it's fine. I'll just get a negative number for my acceleration of the wedge. But for now, let's always try and do kind of make our best guess. And so what that's going on there is we have the acceleration there. Right. That's a lot going on. So what I think I need to do is I need to look at sorry, we had a momentary interruption there. So we've got a few things to worry about here. We've got what are the forces and decomposing the forces that are on A into along the plane and perpendicular to the plane. Similarly with B, along the plane perpendicular to the plane. Figuring out those things, but then because the wedge is moving, the surface that A is on is moving and the surface that B is on is moving. So we're going to have to factor that in, because as the wedge moves, so as it goes across like that, it will, if it goes that way, it'll be pushing into A, so it'll be accelerating A towards the left at the same time as A goes up towards the pulley, and it's going to be pulling away from B. If we look at B now, we're pulling away from B, and I'm not sure how that's going to react. Is that going to be helping it go up or down? Well, we'll find out. So I have an intuition about some of it, but some of it I also don't. So what I'm going to do is I'm going to take a little screen grab of, actually no, I won't, I just draw it, of the A and what's happening to A, what's happening to B, what's happening to wedge. I'm going to fill those in separately as much as I can, and then if something happens in one that I need to take care of in the others, I will do that. So let's have a look. So we have for A, in theory we're going to draw quite big, but I know I'm going to run out of space. So A, what have we said? We have said that we're going to it's going to accelerate up that way, and what's happening is it is being pulled up by the string. So we have tension that way, and then we have our mg down, so gravity, the earth is pulling that, and we know that's 30 degrees, and this, we'll call this A because it's called A. So we've that and we've this. So those are the three forces acting on the particle A. So in order to be able to calculate this stuff and do stuff with this, we need to decompose everything so it's perpendicular and parallel to the plane. Now T is already parallel, or A is already perpendicular, so we only need to deal with mg. So what we do is we go from where it starts here, and we go perpendicular, make a right angle, and go parallel. Because what that lets us do is we can know that, or we can figure it out, or we can just know that that's 30 degrees. So the component from gravity that's pulling A into the surface is mg cos 30, and the component of gravity that's pulling A down along the surface is mg sine 30. So for now, and if the wedge wasn't moving, this is all we would have to do. But because the wedge is moving, we have another acceleration coming, but we will worry, and definitely worry about that when we need to. So what I'm going to do is I'm going to move and kind of copy this with B over to the right, and then we're going to look at the wedge, and then we're going to see how do we cope with the wedge moving. So build it up slowly, can do what we know, and we know that this is what A is experiencing for now. So the next one is we have our surface, that the angle is actually much bigger than it isn't real, but anyway, 30 degrees. We have our particle or our mass, and what's happening is the string is pulling it up, pulling it up with tension T, same tension because it's the same mass. We reckon the thing is going to accelerate downwards. Again, if we get it wrong, we'll get a negative for A, which means we just got the direction opposite, which is cool. And then we have gravity 2mg, because remember the mass of B was 2m. Then again, to decompose this, oh, actually before we decompose, let's get this reaction, the reaction of B. Now before I'm using or A and or B because that's what is intuitive to me. I know the marking scheme uses or1 and or2. It's whatever you're happy with. If you like the way the marking scheme looks, use those things. I know they use A and Q, I think, or P and Q as the accelerations. I prefer A and B because it's just what I do. So it's whatever. It's all personal taste. You get the same answer. It doesn't matter what you call things so long as you get it right. So that's 30 there. We know that that's 30 if you care enough. If we look at this triangle here, that's a right angle triangle with 30 here, which means it has 60 here because that's 90. So it is 30, 60, but we also know that this line is perpendicular, so it means that this thing is a 90-degree angle, which means if that's 60, that one has to be 30. But anyway, I digress. Let's get on to getting the solution. So this is 2mg cos 30, and this one here is 2mg sine 30. So into the plane is cos 30 and along the plane is sine 30. And again, if that was a static surface, that's all we could need to do. We would be able to add friction if we wanted. But for now, that's all we can do until we figured out what are the consequences of the wedge moving, which is what I'm going to do next. So again, pause it if necessary. So the wedge then is this guy here. So the wedge has 230 degrees. That's supposed to be it. Ignore my awful drawing. So what's going on now? So the wedge has 3mg down. It has the reaction up. Now here's where it gets, I suppose, interesting for me, probably slightly hateful for you guys, is we have a pulley there and there's a string. That string is wrapped around the pulley. It's supposed to be taut, I can't draw. So that string is on the pulley, so that string has been supported by the pulley, so it's pulling down or pulling along. There's a tension along the line of the string, T and T. And we're going to worry about that later, and I'm actually going to redraw those just to extend them because we might need a bit more space when we come to figuring out those things, because there's going to be a lot of triangles all over the place. So that's one thing that's happening. So our string is pulling down on the thing, which is adding to its weight or force into the table. But here's where the key part. So this is key here, what I'm about to say, and it's about, from this diagram here, A and B are pushing into the wedge, which means because A is sitting on the wedge, it is adding to its force downwards, its weight downwards, if you will. And it's pushing, A is pushing onto the wedge, so A is pushing to the right and down. And B is pushing, well, twice the amount down and probably twice the amount to the right. I think that's what it is, but we'll figure that one out. So what's actually happening here is if A is experiencing a reaction from the wedge is experiencing an equal and opposite reaction from A. Hence the whole equal and opposite reaction thing. So what we have to do now is we have to realize that forces here are, we have an OR A pushing in and we have an OR B pushing in, which is, it's something. And what we say is happening, what we think is happening, is that this thing is moving across with B. So what's going on now is we have to decompose anything here into horizontals and verticals. So I'm going to look at the ORA first of all. I'm just going to get this and move this over here. So we just edit away. My OneNote is looking very strange due to the video capture, but we'll figure that one out. So what's happening is, in terms of horizontals and verticals, a certain amount of ORA is pushing down, and a certain amount of ORB is pushing down, and a certain amount of ORB is pushing across, and a certain amount of ORA is pushing across. Now, what's the angle here? Well, actually, if we look at this triangle again, we can see from that triangle that there is 60. Which means that, I think that means that there is 30. And that there is 30, yes it does. So I'm going to just delete that 60 just so I have a bit of space to write one of the many, many decompositions we're doing in this one. So this here is OR A cos 30 down and OR B cos 30 down and OR A sine 30 to the right and OR B sine 30 to the left. I need to think we're done, but we haven't decomposed our tensions. It's simple enough because they're identical, because they're both 30 degrees. But what we have to do with our tensions is a certain amount of the tension is pushing down from string on the right, and a certain amount is pulling it to the right. Then a certain amount is pulling it down from the string on the left, and a certain amount is pulling it to the left. But actually that angle there is 30 degrees again. So what we've got going on here is we've got T cos 30 to the right and T cos 30 to the left. And then we have, this guy is T sine 30 down, and this guy is T sine 30 down. Chances are, I've a sneaking suspicion we're not going to need any of this stuff, but it's good to know. So if those angles were different, we'd have to do this, and we'd have different amounts. But they're not different, so let's pretend that's not happening right now. So that's what's going on here. With the wedge, we have dealt with A and B pushing into the wedge with the reactions. There's tension, the reaction on the table, the acceleration, and the mass of the wedge itself. I think that's everything that's happening in the wedge. So let's look at the diagram. Actually, let's look at the non-messy one here, get a handle on it. So on this diagram for the wedge, we have A pushing in, B oops, B pushing in, A pushing in. We have tension here and tension here. We have the mass of the wedge. We have the reaction up. Okay, I think that's everything done for the wedge. I say think, I know, I'm just trying to add a bit of drama in this. So that's everything we've done. So let's, I think the best thing to do now is, now that we're confident the wedge is kind of solved here and all these god awful arrows, let's just have a look at how that affects our equations of motion. So if we look at the wedge, first of all, and if we go horizontally first, so remembering that everything is F equals ma. So we're going to say the acceleration or the force that the wedge undergoes, the resultant force, is our F is our 3mb, and that's in the left direction. So what are the forces that are pushing the wedge to the left? That would be t cos 30 plus or b sine 30 and I'm just going to highlight them here temporarily. Those are the only two arrows pushing it to the left, I think. And then what we have to do is we got to take away a t cos 30 and an or a sine 30, I think. Oh, use the correct pen will be useful. So minus t cos 30 minus or a sine 30. And actually the t cos 30's cancel, which is because it's symmetric and also nice. So 3mb equals, now sine 30 is in the tables. If we look and again pause it here on page 13 of your tables, sine 30 is a half. I'm looking at my tables now, you can see. So this turns into or b over 2 and or a sine 30, so it's minus or a. That's supposed to be an or. I think we deserve a rewrite on that one. Or a over 2. So that's the horizontal equations of motion for the wedge. Now, the question says we just want B. Now, what we do, if we weren't paying attention, what we would do now is we'd do the verticals and we'd get an equation for all the ups equaling the downs because it's not moving up and down. But I think to save time here, I'm just, because I know we want B, I'm just going to stop there with the wedge and see what we need to do for A and B, knowing that I still have the horizontal equation of motion. If for some reason I can't finish the question, I can still go to this one and see what's happening. So we're going to leave that for later if necessary. So we have the vertical one if necessary. So that or B minus or A looks nice and simple and hopeful, and like all good mathematicians and physicists, we want simplicity and beauty over truth, I guess. So let's hope it's the truth. So now, what's going on here? We have looked at the wedge. Again, pause it and go back over it, catch your breath, and then come back. But what's happening here is this B thing here. The acceleration B is moving the wedge, where it's moving the wedge that way. It's pushing things across. So actually the A is accelerating up the slope, we think, but it's also being accelerated towards the left because of the wedge. So what's going on here, and here's why I haven't touched the orange yet, I want to make this obvious, is that we have the acceleration B is pushing A to the left. So what we have to do, and actually just before we go, it's also going to be pushing B, or pulling away from B. So it's going to do something strange there, I think. It's easier to imagine it pushing than pulling away. I think what it's going to seem like is B gets lighter or something, but I don't think we need to worry about the concept just yet. Maybe not even ever. So we need to decompose these B's into perpendicular and parallel to the plane. So perpendicular, parallel, that's 30 degrees again. That 30 is doing loads of work for us. So this is B sine 30 into the plane and B cos 30 down the plane. Okay. And then this one is doing what? Again, we do our perpendicular, we write our 30 degrees. And it's going up and down. Remember, the way to know what to do is we started there and we finished there. So in our triangle, we have to start here and go up and down to finish in the same point. So our start and our finish are in the same point. So we started here, we went along to here. So we go up and down. It is one of the things about vectors from the old maths course that enabled us to be sneaky and create our own stuff, and which is gone. So it's something I'm sad we've lost, but I'll shut up about it. So then we have B sine 30 into the plane, and then B cos 30 up the plane. And those are the accelerations, and we have to remember to multiply them by the masses. So there's an awful lot of trigonometry here, but I think if we go step by step, it is manageable. So where are we at now? We're at 27 minutes. Right, this is more time than you're going to be using anyway. But anyway, let's not dwell on that. So what I'm going to do is I'm going to just copy this A diagram down just so we can read off it as we create the equations. Then I'll just delete it. And then we'll do the same for B. Just in the exam, you have the thing there. You don't. This is just enabling us to see. So if we go for, let's say, A, and we say, let's go horizontally for A for now. No, actually, you know what? In our wedge, there's no tension. So what I'm going to do is I'm going to ignore the tension one for now. I'm going to see, can I get away with not doing the tension equation? So I'm just going to do the vertical ones. Again, if you don't spot this and you write them all down, that's perfect. You'll definitely get the full marks for writing down the equations. So don't spend time worrying about which one is which. Just get them all down if you need to. But for your sake, I'm going to save time. So horizontally. So what is it doing horizontally? Normally, we kind of put the into the planes equal the out of the planes, because reaction's an equal and opposite reaction, because the thing isn't moving up and down perpendicular to the plane. But in this case, it is moving. We have a B sine 30. So the B sine 30 is the acceleration of that block perpendicular to the plane. So our equation becomes F equals ma again. Remember, F equals ma. What that becomes is mb sine 30 equals, now that's up, so that equals RA minus mg cos 30. Oh, that's interesting, because that could give us RA maybe. Okay, cool. So again, page 13 in your tables, sine 30 cos 30 there, so sine 30 is a half, so this turns into mb over 2 equals RA minus mg root 3 all over 2. Okay, cool. I think we don't need to do the one with the tension. I think we're going to be able to solve this without it. So that is our A. What I'm going to do now is I'm going to just do the same copy as I'm going to leave the diagram there just in case you guys want to look at the OneNote in your own time. So it did say encoding overloaded there, so hopefully it's not broken. So we're going to look at the B. What's going on? Oh, so it did not like that. That's what happened. I did a screenshot on that. Okay, sorry. So let's hope that this just works. Go down here and look at B again. Cool. So, and with B, we're going to again look at the horizontal vectors here. And again, we have, normally this thing isn't moving up and down relative to the plane, and it isn't, but the plane itself is moving. So it is accelerating. So this is 2mb sine 30 equals, this time it's 2mg cos 30 minus RB. So this is the resultant acceleration of B, and it's caused by gravity pulling it into the plane and the reaction pushing back. And the difference between the two is the acceleration into the plane. So 2mg cos 30 minus RB. And again, sine 30 is a half. So that's 2mb over 2. And this is 2mg cos 30 is root 3 over 2. So actually this goes to mb equals mg root 3 minus RB. Okay. Now again, pause this to make sure you're happy. But what we're going to do now is we're going to see what can we do with our wedge equation. We've got our A equation and our B equation, and I have a sneaking hopeful suspicion that it's all going to just work out nicely with C. So what I'm going to do, I'm just going to copy the wedge equation down. I know I normally call them 1, 2, 3, but actually I'm just going to call it W, A, and B here, just so we know what we're talking about. So that's our W. So W is that thing. Okay. Our A equation is A equation, and then we're going to have a B equation. The B is right there, so I'm going to take that, put that there. And then the A equation is this guy. Copy that and bring that down there. Okay, and I'm going to shrink this B a little bit because I got my zoom out wrong. Okay, so this is what we have. So we are trusting that what we've got is correct. Trust your past self and hope for the best. So how do we solve this? Well, I think what we're going to do from A, we're going to get A, from the A equation, we're going to get RA equals. From the B equation, we're going to get RB equals. Then we're going to put those two things into our W, and hopefully stuff will just work. if all the m's cancel out, we can be pretty sure we've got the concept and the process bang on. The numbers, I don't know, hopefully they'll be nice. If they're not, they're not. But if the m's all disappear, then we're happy. So for the A equation, that would be RA equals MB over 2 plus MG root 3 over 2. So we can put that in a second. So we have a RA in terms of M's, B's, and G's. Cool. So that's our A. This is our B. So the RB is, so bring the RB over to the left. So that'll be MG root 3 minus MB. Okay. And now the moment of truth. Again, pause it, make sure you're happy that my algebra is correct. I am pretty sure that it is. Well, I do have the answer in front of me, so if I don't get the answer, I will know I've made a mistake and I'll have to, this video will get longer. So what we're going to do is we're going to replace that RB with this MG root 3 minus MB. And I can do that because I have copy and paste. You have to write it out like an ape. And then we have this RA. I'm going to get rid of the RA. Whoop, my mouse is not happy with me with this whole video recording thing. This better have recorded audio. I realize now I'm just trusting that it will. So I'll just zoom in a tiny bit. So there we have our MG root 3 over 2. That may have been quicker if I just written it out, but anyway, that was different. So that is now our RA. RA is here, and our RB is here. Now we have the algebra, which is painful because we've used so much brain so far. So let's get rid of fractions first. So multiply everything by 2. That gives us 6MB equals MG root 3 minus MB, because we've got rid of that over 2. And then we've got minus MB over 2 plus MG root 3 over 2. Let's get rid of those fractions as well. Just get rid of them all so we have just nice-ish things. So multiply everything by 2 again. That gives us 12MB equals 2mg root 3 minus 2mb minus mb. Again, the multiplies cancel out with a divide, plus mg root 3. Oh, wait, yes, we got it. So, or I think we do, because m is in everything, so we divide out by m. And then let's move everything with b over to the left. So that's 12b plus 2b plus b. Look at me not making that joke. 2g, and then we've got 3g root 3 there, I think. Is it 3? Oh no, I got a sign wrong. I definitely got something. So see the here, well spotted. That should have been a minus because the whole thing in yellow was to be minus, and because of my sloppy writing I didn't spot that, so that should have been minus. So that actually goes to 2g root 3 minus g root 3 is 1g root 3. And then that gives us 15b equals g root 3. So B, the acceleration of the wedge, is g root 3 over 15 meters per second squared if we need it, and I think we're done. What I'm going to do now very quickly is just get the solution, and it is g root 3 over 15. Now, pop it in here, and that is the answer from the marking scheme. So just to reiterate, so that's an awful lot. Now most of that time is me spent talking about it. You'll get this done very quickly because you're just going to fly into the things. That's taking me, what, 40 minutes? But that's because I've kind of gone through it slowly. You're just going to get in, put arrows in, put angles in, and it'll be done. So looking at the marking scheme, and I'm going to write this in, where are we? What color we use for marking scheme? We will use our space pen for the marking scheme. So there we go. So for the marking scheme, just looking at what it is, you got 5 marks. That pen is too thick. So you're going to get 5 marks for the wedge. So 5 marks for this. Okay. Then you get 5 marks for that. It'll draw for me. And you get 5 marks for that. And you get 5 marks for that. So if that's all you did, you stopped there. That's 15 out of, now, what do you think? Is it going to be 15 out of 25, 15 out of 30, 15 out of, it's not 15 out of 15 because there's more work. You actually only get 5 more marks for getting the answer right. So now I did do more lines than I needed and I rewrote stuff, so it looks a lot longer. But where I wrote that 5, just here, here, and here. Everything after that last little orange line, all of this stuff here, all of this is only worth 5 marks. It's like the lion's share, the 75% of the question is gotten from this mess here. And it's not even a mess, it's actually, now that I've given it some space, I think it actually makes a bit of sense what's happening. So make sure your diagrams are right, make sure that you're dealing with any consequences of the situation, and then make sure your first set of equations are as correct as possible, and you'll get 75 without doing anything new or any of the weird algebra to prove whatever. So I hope that has been useful. That is 2022 question 4b, the wedge, and it is done, and thank God it only took 43 minutes. It's better have worked. Okay.